Okay, hello everyone. Let us take up the next problem statement on NS2 simulation. So here is the problem statement. It goes like this. A network consists of n nodes. N is equal to 6. The duplex links between the nodes, and there are two duplex links between n0 and n2, which has some bandwidth and the delay, and also between n1 and n2, which has its own bandwidth and delay. Then there are two simplex links between n2 and n3 and n3 and n2 with the specific bandwidth and the delay. Again, you will have to establish the LAN. You have to establish the LAN between n3, n4 and n5 with the bandwidth as 0.5 Mbps and the delay as 40 milliseconds. So this is where, and they also said that maximum queue size it is of 10. So for that you will have to generate the TCL script. So before we get into the generating the TCL script, so it's as usual, first make sure that you have the 6 nodes. So I say it as you should have the 6 nodes. So like this, totally 6 nodes, and among those 6 nodes, it is something like this. So there are the nodes. This, let me call it as the n0. This is what n0, and this is what n1. Let me consider this as a n2, and this as n3, n4, and finally n5. So like this I'll have to consider 6 nodes. Then I supposed to connect n0 and n2. I supposed to connect n0 and n2, so that let me connect n0 and n2. Okay, so which has the bandwidth as 2 Mbps and the delay as 10 milliseconds. The same way I need to connect n1 and n2. n1 and n2 is connected, right? Then so that's how, those are the two duplex links. Now you need to understand, very importantly, I need to connect n2 and n3 by using the simplex links. So when I say the simplex links, I hope you know that is a one-way traffic. So I should have, this is one simplex link between n2 and n3. That's what n2 and n3. So then I should have one more link between n3 and n2. So I hope you are understanding. So these are the two simplex links. So I'm just denoting by using this arrows. So because one way. So here these links doesn't have arrows. So it means to say that I mean to say it is two-way or two-directional. So only it is, I'm not using any direction for this. So that's how. So links. Now is the point that n3, n4 and n5 should be connected with what? Should be connected with the LAN. I'll have to create a LAN. So that LAN, as of now, I'll be considering it as a physical LAN. In my means it is wired LAN. So I mean because of the LAN structure. So to connect these three nodes, which is n3, n4 and n5, so I'll be connecting through the LAN. So then as usual, I'll have to set the queue size as 10 and perform the simulation, and I need to keep observing the packet flow. So in the other means to say, let's talk about in the form of threshold. So that let us see now. So so for this particular example, now let us start coding. So let me create the file as file.tr. So sorry, not file.tr, it is the file.tcl. Yeah, gedit file.tcl. So now let us create the simulator. So I'll just say that first create the simulator. How to create simulator? I hope you remember. Set ns open new simulator where S caps. And all this We have I have elaborated all these things in my previous slides or previous presentations, which you can also get it from the YouTube directly. So then I'll need to create the trace file. So for which let me use as set ntrace. So trace file. So or simply you can also say it as a tr file, a t file, anything it is left to you, because that is just a variable name which you will be using. So here the name of the file let me give as file.tr, and that I am opening with the write mode, because the trace details I will have to write into that, and that I am going to execute. So that's what ns trace all. So all these things had explained in my previous videos, so you can also get it directly from the YouTube. Yeah, so this is what trace all ntrace. So then again I need to set the nam file. I'll say that n file or nam file. It's again, I repeat, it's all your wish. What's the name you will have to, or you want to give. So it's you can give, and this nam file as n.nam, and I am opening that with the write mode. So again, as usual, I'll have to execute this dot nam trace. So nam trace all. So which file? It is the nam file. So nam file I'll have to do that. So I'm done with this simulator setup and the trace file setup and also the nam file setup. Now let me provide any kind of coloring. So as here I am trying to demonstrate with respect to both TCP and the UDP service. So just to have the difference, so let me make use of the two colors. As color 1 as, yeah, I'll take up it as blue, and I'll go with the one more color as red. I'll go with the second color, one more color, just as a demonstration. You can go with any color. There is nothing like only red and blue. Then I need to create the nodes. I'll say that create nodes, and from the question, I hope you remember how many nodes we'll have to create. It's totally 6 nodes you need to create. As you need to create 6 nodes. So if you remember, I hope you saw the problem. There is a problem. Yeah. So you'll have to create the 6 nodes. That's what. Let us create. And for creating the 6 nodes, I hope you can follow the earlier method. So it is a new node. By using a new node, you can create. Now let me show you other way of creating the nodes by using this for. So I can also make use of this for loop. So set I to 0 until what? Until that I is less than total number of nodes. It is 6. So what I supposed to do? I supposed to keep incrementing I, and inside that let me use this set n of $i. It is the same as n of I. So that I'll be creating as $ns node. So I hope you understood this. This is one more way of creating a multiple nodes. If you want to create too many nodes, just these 3 lines is enough. Instead of you keep listing out the new node, something like set n not new node, set n. So because I hope you let me show you that also. So we used to do this n not here $ns node. So again you go with set n1, again $ns node. Like this we were creating the multiple nodes for we were creating the nodes. But if you want to create multiple nodes like 6 or 7 or 10, instead of having a 10 instructions separately, that you can achieve by using this single loop instruction. So this is enough. By using this for loop you can achieve that. So what I say, so first you initialize the I to 0, then until I becomes until I is less than 6, so you can keep incrementing the value of I. So that's what you keep incrementing the value of I. So for every I you will be creating the node. So it is something like n of I. When I is 0 it will be n naught. When I is equal to 1 it is n1, n2, n3, n till it will be n5. And what you are doing, you are creating the nodes. So that's how you create the 6 nodes. Then let us create the links. I'll say that creating the links. I hope you remembered. So under the links, so you will first let me create the duplex links from our diagram itself. I hope you remember, you can get it from the diagram. N0 and N2 and N1 and N2 should be connected with the duplex link with what? 2 Mbps of bandwidth and 10 milliseconds of delay. Wherein N2 and N3, N3 N2 has to be connected with the simplex links with the 0.3 Mbps of bandwidth and 10 milliseconds of delay. That's what let's see right now. So first let us create $ns duplex hyphen link between what? Between n. So here you can't simply say that n0, it is n of 0 because you are using it as a array. It is something like that. As you are using index like this, you can't simply say that. I repeat this, don't make a note. You can't use this n0. It is n of 0, n of 1 because you are creating the nodes itself like that. N of 0, n of 1, n of 2, n of 3, n of 4, n of 5. So it is $n of 0 and $n of 2. So $n of 2. Then how many? What is the bandwidth? It is the 2 MB. And what is the delay? It is 10 milliseconds. And as usual, the congestion controlling, it is the DropTail mechanism. So like this, I need to create the 2 links. So I need to create one more link like this. So wherein I hope you remembered, it is from 0 to 2 and also between 1 and 2 with the same bandwidth and same delay. That's what created with the duplex link. Now let's create the simplex links. So if you want to create simplex links, I hope you remember. So you need to create the simplex link. So instead of this duplex, what is supposed to be there? It is simplex link between what node? It is between N2 to the N3 with 0.3 Mbps and also 100 milliseconds of delay. Then again the same simplex. So you're supposed to have the simplex link between the N2 and N3. One more simplex link you're supposed to have. So that's what let us have. So start with the $ns. Yeah. So whereas this is between 3 to 2 like this. So as it is simplex link, one way link, so you're supposed to have between 2 and 3, again 3 and 2 with the same bandwidth and delay. So that's how you create. We just created the links between them. Now let us set up the LAN setup. I'll say that LAN setup. So if you remember, between what nodes? Between 3, 4, 5. Between 3, 4, 5 is supposed to establish the LAN. Between 3, 4, 5 is supposed to establish the LAN. So when you want to establish the LAN between 3, 4, 5, what is the bandwidth? There is 0.5 Mbps and also the 40 milliseconds of delay. Now let us establish the LAN. That's what I call it as a LAN setup. I just called it as. So what I will do, I'll just say that set LAN. As usual, remember this LAN, this LAN, this is just a variable. You can say it as any name. There is no constraint for that. Okay, $ns. Whereas this is a system call. You're supposed to use like this itself. New LAN, L caps, between what nodes? If you remember, it is $n of 3 and $n of 4 and $n of 5. So like this, you're supposed to create the LAN between these 3 nodes, or a LAN consisting of 3 nodes with the bandwidth as 0.5 Mbps and also 40 milliseconds of delay. So in which layer you will have to create? It is you are let's assume that as you are creating the, or as you are setting up the LAN, so you will have to do it in the logical link layer, which is a part of data link layer. So I hope you know that link layer and the MAC layer are the 2 sublayers of the data link layer. So we are taking up this link layer LL. Then so what is the mechanism we are following? It is the queue. And so what is the mechanism to mechanism for congestion control? It is as usual, we use DropTail. For the links also we use the same DropTail. Inside the LAN also we are using the same DropTail. And this is the IEEE standard. I hope if you know, it is a Mac standard. For the Mac it is 802.3, but we won't say it as 802 point, it is 802 underscore space 3. It is 802.3, and we're using the channelization mechanism. So like this is where you created the LAN between those three nodes. So you created the LAN between those three nodes. Then again you set up, first let us set up the queue size. I'll say that setting queue size, and I'll also I'll also consider the what I'll say monitoring. So set and monitor, setting and monitoring the queue. So what I will do, first I have to set it. So I'll just say that NS queue length, queue limit between what? Between the n of 2 and n of 3, because if you remember, so I'm bothering about this simplex link. So for this I am just doing that. Between n2 and n3 there are the simplex links. For that I set the queue limit, so which is as 20. I'll set as 20. You can also set as 10 as well, no issue. You can also set as 10. No problem. Then $ns. So which links you set for that? It is on the simplex link op. Which are the ops, which is the nodes for the simplex link? It is the $n2, n of 2 and $n of 3. Q, which is positioned at the 0.5. Q position at the 0.5. So that is where the monitoring of the queue will be happening. So we just set up the nodes and we connected the nodes. We created the LAN as well. Now let us create the agents. So I'll just say that set up agents. So first let me bother about the creating the TCP agent. First let's create the TCP agent. So remember, first let us create the TCP agent. See what we are going to do in the sense right here, as we want to in the question they didn't say that whether we to apply the TCP or the UDP. They just said that observe the packet flow. So for example, or in this example I am going to consider N0 as the TCP source and N1 as the UDP source. So I am going to create the N0 as a TCP agent and the respective sync agent in the LAN nodes. Either it can be N5, N4 or N3, it can be any. So let us take up any of these nodes as the destination nodes, right? So these are the two source nodes, N0 and N1, whereas any of these nodes will be the destination nodes. So in that perspective, considering N0 for me, it is N0 will be the TCP agent. So I'll say that TCP new agent. So I hope you remember all these things, how to create the TCP agent as well. TCP, then I'll have to so what I will do, I'm going to set that I'm going to set it as a I'm going to set this with the respective flow ID as TCP set FID flow ID with 1, right? Then I'll be setting the window size as well, or in the other way you can say that packet size. So remember the packet size which I'll be setting here, it is only meant for the TCP packet, not for the UDP. It is the size of the TCP segment. So then I'll attach $ns attach agent, and to which node I'll be attaching? To the $n0, because already I said I'll be dealing with the N0 as the TCP agent. So N0 TCP. So here this is what agent, right? So that's what we did. Packet size, yeah. Now we created the TCP agent for the N0. So you're supposed to have a similar, there's supposed to be a sync agent as well. So because the destination agent should be there, right? So for collecting the data, so agent slash TCP sync. So TCP sync. So and that TCP sync agent, let me attach that with the, I said any one of the node in the LAN. So and also I said that LAN has a 3 nodes, which is N3, N4 and N5. So as of now, let me consider N4 as the sync agent, so which is to collect the data. So N4 will be acting as sync agent. So now let me connect them. So connecting what? Connecting the TCP agent and connecting the sync agent, connecting TCP and the sync agents together. So I'm done with the creating the TCP agent. Now we need to create the application for the TCP agent. So which is the application? It is the FTP application. I'll say that for TCP. So I need to create the FTP application. So how to create? Again, as usual, FTP new application, and which application? It is the FTP application, right? Then as usual, I'll be setting my own values for the FTP as set type. Which type is this? It is the FTP, right? It is the FTP. Then this FTP agent I'm going to attach with the, what? Attach agent to TCP. So I'll be attaching with the TCP, right? So that's, I'm done with the, so in this what I did, I just created the TCP agent, right? I just created the TCP agent, I created the flow ID, packet size is set up, and attached that TCP agent with the N0. Then I created one more sync agent that attached with the N4, right? So then I created the FTP application that I attached with the TCP. So that's what I'm done with the TCP and all. So now let us go with the UDP. So when I say that UDP, so what and all will be there? I'll just consider this itself. I'll just copy paste and I'll just make the changes where whatever it is required. So I hope you can understand. So here I will be creating what? UDP agent. I'll be creating UDP agent, and this is I'll let me call this as UDP, and this is what? Agent slash what? It is the UDP, right? So I'm done. So I'm done with the creating creating the UDP agent, and this flow ID will be what? 2, and this is what? Is it TCP? It is UDP. Fine. So and then I can also set the it is left to you whether you are going to set the packet size or not. See, for the difference, I'll show you the difference as well. Let me not set the packet size. So I'll show you if you don't set it, what happens. Now I'll be attaching this UDP agent with the, as I said, I'll be attaching with the N1. So as I already said, so as I said, this I'll be considering that UDP sender, right? This will be acting as UDP sender. So see, earlier what for the TCP what I did, I'll consider N0 as a source and N4 as a destination. So now I'll be considering for UDP N1 as a source and N5 as the destination. I'll be considering N5 as the destination, right? So in that perspective, so what happens? N1 is created as N1 is attached to the 1. So then for so I hope you remembered, for the UDP it is not the null agent, it is the it is not the sync agent, it is the null agent, right? So in that perspective it is null agent. So I'll be attaching that null agent with what? So as I already said, we'll be considering 5 as the node 5 as the receiver node. So here connecting what and what? Connecting UDP, connecting UDP and null. So I connected UDP and the null. So then which application I'll be creating? It is the CBR. It is CBR for the UDP. So for UDP we'll be creating the CBR. So again, as usual, set CBR. So new application, and what is this? Is it TCP? No, it is traffic slash CBR traffic slash CBR. Then again, as usually, it is a what type of traffic? It is the CBR. Then we will be attaching the to the UDP. What you will be attaching? Remember, what will be attaching? It will be doing all these things with what? The CBR, not with the FTP. Remember that. So I'm done with the attaching that CBR with the UDP. So I'm done with this. So again, that's what I already said. It is left to you whether to set the particular packet size or not, which I already said. So I attached that CBR with the UDP. So okay, so I'm done with this setting up the UDP as well. Then later, now let us go to the procedure. So coming to the procedure finish. So in the finish procedure, what we supposed to do, we just need to first declare all the variables whatever you used. I just used as ns, ntrace, again I used it as nam file, I used as nam file as well, right? We use this nam file, right? Then I'll have to flush everything. That's what flush trace. So flush trace. Right after that, I'll be just closing the $ns $n_trace. Again close. What will be closing? What is the file? It is a nam file. Yeah. Then I'll be calling the execution for what? For executing the animation file. Py.nam. Right. So I'll be calling the animation file for execution. So then right after that, exit 0. So I'm done with the finished procedure as well. Now finally let us scheduling the events. Let me call that as a scheduling the event scheduling, right? So under the event scheduling, so as usual, first let us start with the, so at 0.01. so first let me start with the CBR first. So CBR start, right? So then later let me start with the, once after I started the CBR, then I'll start the FTP. So FTP I'll start somewhere after 0.5, right? So I'll start somewhere after 0.5, or even I'll say that at 1 second. So I may be starting the CBR at the 0.1 second. I may start the FTP at the 1 second. Then I need to stop them, right? So stop. So here let me stop the FTP first. So let me assume that, let me stop it at the 24th second. So I'll say the 24, right? Then again, so let me stop the CBR at let me assume that 25. Okay, so this is where I'll consider that, yeah, stop. So yeah, you can consider it as 24 or 24.5. Again I repeat, it's all based on your assumption and based on the whatever you set up. Based on that you need to prove your result. That's it. So ns at, so at 25th second I'll just call the finish, which is the ending your simulation. Now let me call the simulation. So ns run. So I'm done with the coding part. So now let me compile it. So if I have any errors, let us clear them as well. Okay, so yeah, there is error at the line number 43. Now let us take up that. What is there in the line number 43? Line number 43. Yeah, this is what the line number 43. Even that's what. So basically I forgot that to give $ns the same way here as well. It is not directly, you can't make use of connect directly, right? So that's what the mistake what we did. $ns followed by connect. Okay, let's run now. Yeah, now I hope you can see this. I want you to observe this clearly. I said that we have created the 6 nodes. So N0 is here, N1 is here, N2 is here, N0 and N2 connected with the duplex links, N2 is connected with the N3 with the simplex links. Everything is fine. What about this LAN? So this, if you observe this, I said that 3, 4, 5 should be connected with the LAN. So it is connected, but you see this simulation picture, which is something which is like, you know, it don't looks good, right? Even though they are connected and they can perform well. So for that purpose, that's what, to make them to be clear, I repeat again, so let us write down the connectivity is, everything is fine. 0 is connected to 2, 1 is connected to 2 is in duplex, 2 is connected with the 3 with the simplex, whereas 3, 4, 5 are connected with the LAN. They are actually connected equally, but placement is not that good. So for that, so now let me show you a few lines of code how to place them in a proper manner or properly. So right after I create the LAN here, so here let me set up that, I'll say that like, you know, orientation or the position or placement, placing those nodes at the respective position. So I hope you remembered which are all the nodes. It is the like, you know, the nodes belongs to the duplex link. The nodes belongs to the duplex links. Which are all the nodes belongs to the duplex link? It is what? N0 and N2. So I'll say that $n of 0 and $n of 2. So they have to, let me orient them to the right. So I'll say that right down. So then same kind of one, we have one more duplex link as well. So we have one more duplex link as well, which is that one more duplex link. I hope you remember, it is 1 and 2, the duplex link between 1 and the 2. So I'll say that it is right up. So whereas we have one simplex link actually between 2 and the 3. So between 2 and the 3 we have one simplex link. So that let me place here as simplex link. Let me place between 2 and the 3. With respect to the LAN, let me orient it to the right side. Okay, so I'm just give a few placements. Now you can observe the structure of the LAN, how it looks like. So this is what the final structure of the LAN which I was talking about. So this is what 0 to 2 is duplex, again 1 to 2 is duplex, whereas from 2 to 3 it is simplex, from 3 to 5, 3, 4, 5 these are connected with the LAN, right? So that's what. Now let me simulate. You can observe the simulation. So where for the differentiation, one, it is the if you remember, one is what? It is the UDP sender, right? UDP sender, whereas 0 is what? The TCP sender. So you can observe after 1 minute, the UDP, that's what right after this 1 minute, this 0 starts sending. TCP sender will start sending after this 1 minute. You can observe. So that will happen. Yeah, that will happen after. See, is it visible? I hope you can make it out. So from this, so there is and also you can also make one more point very clearly, that so you can observe that there is a continuous flow of the UDP transmission, but actually TCP transmission is happening, but that you can see it is, which is negligible. I will show you in the trace file. The TCP transmission is happening, but which looks like negligible, which is because we didn't set the rate of transmission for the UDP. When you don't set the rate of transmission for the UDP, it will be keep throwing the data. It will be like this. Now when it will be keep throwing the data, so so this, and also this is the simplex link between 2 and 3 is the simplex. The TCP is not at all getting a chance to transfer. Here there is a problem which is happening in the code. I'm going to show you that line as well. So where we didn't set the rate of transmission, as you don't set the rate of transmission, what is happening, the UDP is only completely throwing, where the TCP, you feel that TCP is not at all sending, but actually it is sending, so which is purely negligible. So that I will show you. So with the file.ti, in the trace file you can observe, so you can observe like this. So right after every second you are getting I mean, so you can feel that there is a transmission of CBR. But so what I am saying, it is like, you know, TCP is not at all getting a chance for the transmission, because you didn't set up, you didn't set the rate of transmission for the, see, can you see, this is what I said, TCP is actually transferring, TCP is actually transferring. We don't say that TCP is not at all happening. TCP is happening, but it is purely negligible, because UDP is dominating like anything, because you didn't set the rate of transmission, you didn't set the specific delay for the transmitting the UDP data. When you didn't set that delay or the rate of transmission for the UDP, so it is continuously throwing the data. So in that continuous manner, whenever it is showing, whenever it is throwing continuously, the TCP is not at all getting a chance to transfer in the simplex link. So because I said, so this is the, you observe, this is the simplex link, only one transmission can happen at a time. So in that perspective, when UDP itself is dominating, TCP is not getting a chance. How to control this? How to control this? That is what we need to, we supposed to have a, are you supposed to set the rate of transmission. So how to set that rate of transmission? How to set that rate of transmission? So let me go to that what I say, yeah, TCL file. So in that, here in the CBR, as soon as I created the application, where is it? Yeah, as soon as I created the application here, and I set the type as well, and this is where I supposed to set the rate. So CBR set rate, you can observe it is 0.1 MB. So I'll set as 0.1 MB. Now you see the difference. If you see the difference right now, can you see what is the flow? I hope you can observe this clearly right now. Earlier you could not able to see the blue at all. Now you can see the difference, because now you made the rate of this transmitting the UDP packets somewhat lesser compared to the previous case. You can also make it even, now I set as only 0.1 MB. If you say it as 0.01 MB, so it will be even less. That's what the very important thing I want you to observe it right here. So from 0 you are sending the data to the LAN, which is TCP data. From 1 you are sending the UDP data. So that is, so earlier case what I shown, when you don't set the when you don't control the UDP was dominating in this simplex link like anything, whereas TCP was not getting any chance. And one more thing, now you can observe there is a acknowledgement only for the TCP, there is no acknowledgement for the UDP as usual, the general concept which deals with. So, and one other point you can, if you observe the data which is transferring through this simplex link, so it is only one data at a time, either it can be UDP or it can be a TCP data, but it is only of one data at a time, right? So I hope you are getting this as well. So now let me close this and I will show you the trace file, the same trace file. I'll let me open and show you. So now you see what is the range of, what is the availability of those TCPs you can see. So there will be plenty of TCPs you can see, because now the UDP has not dominated much, because you set the specific rate of transmission of the UDP. So there was a possibility. That's the first case. Now let me go to the next case. Okay, before we go to the next case, it is where we need to observe this packet flow. So now let me consider that in the form of a throughput. So what is the rate of incoming throughput and what is the rate of outgoing throughput? So based on that, let us observe this packet flow. See, even before that, let me show you one more thing here. So in the trace file, whatever we opened here, so in the last experiments and all, I said you this is the event, a trace event, which is plus NQ, R is minus is the DQ, R is what receiving, and whenever there is a D, which is for the drop of the data. So I hope you remember that these are the cases. D stands for drop. But I didn't tell you till now in the my last videos as well what is this H. Basically this event type which varies based on the kind of communication you will be having. So in this case it is what H is for hop. So which hop, from which hop, and you are getting that data transmission. So that's what hop, H for hop event. At the event which is happening in the hop, that is what H stands for. So now let me go back and show you the analyzing the packet flow. This is what analyzing the packet flow. So remember this analyzing the packet flow is nothing else. Analyzing the packet flow is nothing else than the analyzing the throughput. So again, with respect to our case, throughput is the two types of data flow which is happening in our case. One is the TCP, other is the UDP. So both we supposed to consider. So for considering that itself, so first you need to find out the throughput. Again, remember from where you can find out the throughput, in the sense in the other way. Let's take up in a simple example throughput, how to find out the throughput. So throughput, you can find out the throughput. So how to find out the throughput, in the sense, remember for either it can be TCP or it can be for UDP. So you'll have to first find out the number of packets. So it can be TCP or UDP. So I'm just taking this normal way. Number of packets into size of each packet. So size of each packet, and also finally how much time the transmission has occurred. So which is, I'll say that time. So based on this itself we do find out the throughput. So for example let us take up here something like, if the number of packets, if you are transferring 50 packets, I'm just taking an example, 50 packets, and size of each packet is also 50 bytes. Let's assume size of each packet is also 50 bytes, and you are doing the transmission for 5 seconds. So it will be something like, you remember, so it is what 50 into 50 divided by 5 seconds. It is what like this. That's how you do find out. So remember, that's what 50 into 50, whatever you get, that divided by 5. So this is what 500 is the throughput. So for this it is what 500 is the throughput. So remember, this is the formula to find out. Now is the question that from where do we get this number of packets? From where do we get this size of the packet? That is what my question. So remember, from our scenario we have the trace file. In that trace file, first classify the TCP packets and the UDP packets. So you may classify the TCP and the UDP packets, you will be classifying as CBR packets, because I hope you can observe from the trace file, you can observe these are the UDP packets which has the CBR in it. So remember, which has CBR in it. So that is what the CBR data, which is the UDP data, and whichever has the TCP in it. So those are the TCP. So can you see this? These are the TCP files or TCP packets. So like that, you need to first classify which are all the TCP and which are all the UDP packets. From that, find out the number of packets. How many TCPs are there? How many UDPs are there? Based on that, you find out number of packets. Either it can be TCP or UDP. Remember, the formula remains same. So find out number of TCP, number of UDP separately. Then find out the size of each packet. So how to find out size of each packet? Again, let me go to the trace file. Remember, this is the size field. So if you remember, this is the event, this is the time, this is the from node, this is the to node, this is the type of the packet, which is CBR or it can be TCP, and this is what very importantly, size of the packet. Remember, this is the size of the packet. So this is the, when you say the size of the packet, so as I already said, once after you classified the TCP and the UDPs, so from that you got to know how many TCPs are there, how many UDPs are there. So that based on that you will get the number of packets. Then size of each packet, how to get size of each packet? That you can get it from the sixth field. So you can observe this is the first, second field, third field, fourth field, fifth field, and the sixth field in the trace file. So from that you will get this size of each packet. You will get from the sixth field. Remember that sixth field. From that you will get that. Then as usual you fix the time. You fix based on the simulation. Based on simulation you fix the time. So by having these three fields you can obviously find out the throughput for the TCP and throughput for the UDP. That is very important. I want you to understand the same formula. I hope you see this. The same formula. First you get the number of packets based on this TCPs and UDPs. Then find out the each size of each packet. Then you multiply that divided by this simulation time. That's what we do take up that. So I hope you can observe. Now let's get into the coding. So and way to insert. So I'm inserting before I exit. So right after I execute and before I exit, that is where. So first let me declare the TCP size. So what is the size of in the other way, let me say that what is the size of each packet. So even before that you can also say the number of TCP packets as well. So there is no problem at all. So I'll be just using the grep Linux command. So I'll be whichever the file in that tr file. So I'll say that file.tr is the trace file. So in that trace file, whichever starts with, that's what, cap with r, so that I'll be in the file. So that you will be selecting. Remember, in the inside this file.tr file, every instruction. So every instruction whichever start with the that's what starting with, that you are going to represent with this cap with the r event, which is the receive event. So I hope you know this. grep is the global regular expression print. That's what the it is a kind of command line utility which is used for searching for the plain text in the given data set. So basically it matches based on the regular expression. Now is the regular expression is what start with r, in which in the file.tr. Again from that you need to classify which are all having the TCP, because now I am considering only the TCP segments. Once I classify that TCP, that I will be cutting based on the, that's what D. So I will be neglecting the rest. I will be only considering the field 6, because I hope you know why I am considering only 6. Only 6th field is having the size of that packet. That itself I am storing it as size. So that I'll be pushed to this TCP size. For that I'll make use of tail -n1. So what has happened now? So I can open the file. From that file I read each and every instruction, each and every line which start with the R. In that I categorized only TCP lines. From that I consider only the 6th field, that I am going to sum up and push into this TCP size. So I got the TCP size of each packet. So that let me so what I will do before that, first let us find out the next parameter which I want is number of TCP packets. So I'll say that num TCP. Again as usual execute grep. So again start with the R. So in which file? It is in the file.tr. So in that I need to I need to count the number of TCPs available in that. So that's it, number of TCPs, because I need to find out the number of TCP packets. So I'm done. Now what I will do, I need to have the third parameter. If you remember, I need to have the time. I'll say the TCP time. So this TCP's time I'll set as 23. See why I'll be setting as 23 in the sense, if you remember, here I'm stopping the TCP process, which is FTP process at the 24. So here I'll set as 23. You can also set as 24, no issue. So based on this, now I'll be formulating a formula. What is that formula? I'll so formulate, and also I'll be displaying. So puts, so what is that expression? So inside that, I hope you remembered, it is first I'll need to consider the number of TCP segments. It is NTCP. This is what NTCP, number of TCP into, so take up the next, which is what TCP size. This one TCP size, that you need to divide by what? TCP time. That is what the formula what we used, if you remember. That's what the formula we used, time. So in the same way TCP time. So that I'll be just closing. So it is what? Bytes per second. So this is what we found for the TCP. And remember, this is for the TCP, not for the UDP. So I'll just use that statement also. The throughput of FTP is this. Next, in the same way I need to find out for the UDP as well. So for finding out the UDP as well, so again I'll take up this same. So I'll just declare, instead of TCP I'll just say that UDP, right? So okay, in normal way, let me use as UDP size. So again, as usual, first grep it in the 5.tr, read that, and from like which and all you need to select. Remember, it is the CBR. There is nothing like UDP. I hope you remembered. Again, from that same sixth field, that you need to sum up and push it to the UDP size. Then here let me take up as number of UDP segments, and here what and all you are supposed to consider, it is the CBR, and here let me set some value as UDP time. Again, as usual, here let me set this as a 24 because my simulation is ending. UDP simulation ends at the, you can see it is at the 24, so I am taking it as a 24. Okay, so again, as usual, this let me take up this, and let us do it same way. Throughput for the instead of now throughput for the FTP, it is for the CBR application. So throughput for the CBR application, as usual, expression. Now it is number of, instead of TCP, it is what number of this is what UDP, not UCP, UDP. Again, as usual, this is what UDP size, right, divided by UDP time. That's what, so many bytes per second. So remember, I just found what I classified which are all the lines belongs to the TCP and the UDP. From that I found the size from the sixth field, that I called as the TCP size and the UDP size, and how many TCP packets are there and how many UDP packets are there, that I multiplied by divided by the time. So that is based on that I can get the total throughput. So let me run and show you that. So yeah, so there is error. Let us see that error right now. You can see there is simulation will happen because the error is nowhere belongs to that. So now what is this? No, yeah, no such file for the grep. I got the error which is in the, okay, that's okay, we will clear. Yeah, this is where I'm supposed to leave space. Okay, is it clear right now? Thank you. Now you can observe. Again, still there is a time. Okay, TCP time variable, there is no such variable, that we will see now. TCP time. Yeah, okay, this is what set TCP time. It's not equal because it is Linux. Yeah, this is what I want you to observe. Now can you see this? This is what the complete throughput for the FTP. So many bytes are transmitted per second. This is what so many bytes are transmitted per second with respect to the CBR. That's what I said. So when you have so many packets, and what is the size of each packet and how much time you transfer, so that you will get to know what is the total number of bytes you transmitted per second. So in the same way we identified here, right? That's what the complete program for your current problem which we considered today. So if at all if you want to make me again or show me the program again, so let me highlight. So first what we did, we just declare that we created that simulator trace file, NAM file as well. We created the multiple 6 nodes. We connected them by using the duplex and the simplex. We created the LAN as well. This is what LAN creation with the 802.3. Then we are given the position for each and every node instead of having the random position. Then we set the specific size of the queue, and finally we created the TCP agent for the N0 and the sync agent for the N4, and we created the UDP agent for the N1 and CBR agent for the null agent for the N5. Application is CBR application. Then here inside this finish, we wanted to find out the throughput, whatever throughput of FTP and throughput of CBR. So we use the formulas, and for fetching the respective values from the trace file, we use this grep. We use the grep, right? So that's the complete program. So now if at all if you want to see this, you can also see this throughput. And now coming to the simulation, that's already said. So this is what the sender for, and this is the receiver. This is the sender and this is the receiver, and this is the LAN. Remember, this is the bus and this is the LAN, and this is the duplex links and this is the simplex link. And so for the, and now it is what is happening, it is the what is happening now, this is the let me just for a moment, what is happening, it is the UDP transmission is happening when node 1 is sending to the node 5. You can observe clearly, node 1 is sending to the node 5. As soon as it enters to the LAN, so it will deliver to the 4 as well. So that's what is going to happen. It will be delivered to the 4 as well, but 4 will not accept the data. It is simply dropping the data, which you can observe clearly. 4 is not receiving and accepting, it is simply dropping the data whatever is sent by the 1, as it is UDP case, and it is a LAN. In the LAN, whatever it is received, it will be delivered to the both the nodes. You can observe that clearly. 4 is not accepting, it is simply rejecting. Whereas in the same way, whatever is sent by the 0, it's supposed to be delivered to the 4, but when it comes to the LAN, it will be delivered to the both 5 and the 4 as well. But 5 will not accept it, it is simply rejecting. That's what dropping the data. That you need to make it sure. In the LAN, only 4 is accepting the data whatever is sent by the 0, and 5 will receive but it will not accept, it will be dropping the data, which you can observe. And the blue data is the TCP and the red is the UDP, and for every blue TCP data there is a acknowledgement back to the respective source. That is the complete demonstration of this experiment. I hope you understand, right? So then, as I already said, you will have to see the trace file, and this is what the throughput for the FTP and throughput for the UDP, right? I hope you understand. Okay, thank you for your time.